Hey Troy, appreciated the last video you made demonstrating the difference between the heavy arrows and the light arrows at 45 yards when they were both hitting on at 40, and then seeing what the difference was. And the difference was pretty small. I think it was a 1/4 inch, and that's not surprising because of the angle of fall. So the angle of fall is the least angle measured clockwise from the horizontal to a line tangent to the trajectory at a level point. So what that is as your trajectory is arcing down, if you draw a tangent to where it crosses the horizontal plane, it forms an angle on this side, and that's your angle of fall. I'll zoom into that in a bit, but that is very closely correlated with its angle of departure, no matter if it's a bow or a rifle, or in this case, an artillery piece. The angle of departure, the angle at which you launch something, is very, very similar to what that angle of fall is. Now, in a vacuum, they would be equal, but because we have air resistance and consequently velocity erosion over time, the angle of fall in the real world is always going to be steeper than the angle of departure. So in the case of a rifle or a howitzer or a bow, if you have a fixed energy source, right, same charge for 2 different bullets or 2 different shells, or same poundage for 2 different arrows, right, and you have a heavier and a lighter, you're gonna have a velocity difference. This is ultimately a velocity issue, right? So with the lighter projectile going a bit faster from the same platform, it doesn't take as much elevation from the horizontal to achieve your desired range. Conversely, for that same range, you're gonna need more elevation from that same platform to achieve that range. And this is not anything new, but the reason this is important, and I'll get into the angles in a minute, is because most people, when they do this test, they're using one aiming solution for 2 projectiles. You were using 2 different aiming solutions for 1 range. Most people will use an aiming solution for a lighter projectile, and then they'll shoot a heavier projectile, and most of the time it's gonna fall short. There are exceptions to that at very long range, but that gets into ballistic coefficient, and other people cover that better than I do. But at most ranges, the slower projectile, the heavier one, is not gonna be able to catch up in time to overcome that. And that's not a fair comparison. And everyone observes that this distance, the falling short on the horizontal plane, or consequently dropping very low on the vertical plane, is very observable. But going back and zooming into the angle of fall. So the angle of fall is what gives you that difference in your arrows. So you had your lighter arrows coming in at a shallower angle, right? It doesn't take as much tilt in your bow wrist to launch them. Therefore, it's coming in at a shallower angle, crosses, right? This was your aiming point at 40. Both the heavy and the light were hitting at 40, but you moved the target. You introduced range error. So you had an aiming solution to 1 range, but the target was physically at another range. So you were hitting at 40, but you moved the target to 45. Well, the lighter arrow is going to continue until it hits something, and so it hit low. The heavier arrow continued until it hit something, and it also hit low. But the difference between these two, the reason they're measurable, is because of the angles of fall. Now, they're obviously very observable. You can just walk up and measure this, but that's the nitty-gritty of why that's important. So also to give scale of how small these differences are, right? You were shooting a bow at 45 yards and you observed a difference between these two of a 1/4 inch. That has to do with your angle of departure more than anything else, right? So the amount that you had to tilt your wrist to shoot the light arrow versus the heavy arrow wasn't a lot. It wasn't like you were holding your bow and then cranked it up 30 degrees